Good day everyone, I am Nina Dukdok, the last reporter of Group 5, and I'm going to discuss about controlled potential coulometry. Controlled potential coulometry is the easiest method of ensuring 100% current efficiency to maintain the working electrode at a constant potential that allows for the analytic's quantitative oxidation or reduction without simultaneously oxidizing or reducing an interfering species. The current flowing through an electrochemical cell under a constant potential is proportional to the analyte's concentration decreases, as does the current. So the picture here, mo na siya ang sample sa controlled potential coulometry. Next, let's proceed to controlled current coulometry. It is a technique that uses a constant current in place of a constant potential, which produces the current versus time profile as shown in the figure. So, mano siya ang formula sa controlled current coulometry. Q is equals to I. Ang I is current na siya times the T is the time. Next, let's proceed to the application of coulometry. First application is quantitative applications. Coulometry may be used for the quantitative analysis of both inorganic and organic compounds. Second is the coulometric titrations. This is advantageous over conventional titrometry because the electrochemical generation of a titrant that reacts immediately with the analyte allows the use of reagents whose instability prevents their preparation and storage as a standard solution. Third is the characterization applications. Studies aimed at characterizing the mechanisms of electrode reactions often make use of coulometry for determining the number of electrons involved in the reaction. So I have here a work example. Example 11.8. The purity of sample of sodium thiosulfate was determined by a coulometric redox titration using I negative as a mediator and 3-iodide as the titrant. A sample weighing 0.1342 grams is transferred to a 100 ml volumetric flask and diluted to volume with distilled water. A 10.00 ml portion is transferred to an electrochemical cell along with 25 ml of 1 mole potassium iodine, 75 ml of a pH 7.0 phosphate buffer, and several drops of a starch indicator solution. Electrolysis at a constant current at 36.45 ampere required 221.8 seconds to reach the starch indicator endpoint. Determine the purity of the sample. So here we will calculate the purity of the sample given in the example 11.8. So this is the solution. From table 11.9, we see that the coulometric titration of S2O3 to the exponent of 2 negative with triiodide is 2S2O3 to the exponent of 2 aqueous plus triiodide aqueous reversible reaction S4O6 to the exponent of 2 aqueous plus triiodide aqueous. Oxidizing S2O3 to the exponent of 2 to S4O6 to the exponent of 2 requires 1 electron per S2O3 to the exponent of 2. So, n is equals to 1. Ang n mo na siya ang katong number of electrons. Combining equations 11.23, which is the Faraday's law, and 11.24, and making an appropriate substitution for moles of Na2S2O3, or the sodium thiosulfate, gives the equation of N times F times the grams of the sodium thiosulfate divided by the FW. FW is formula weight of the sodium thiosulfate is equals to current, which is the I times the T, or the time. Kaya ang grams sa sodium thiosulfate man ang atong pangitaon, so ang formula mahimo na siyang grams of sodium thiosulfate is equals to current times time times the formula weight of the sodium thiosulfate divided by the number of electrons times the Faraday's constant Coulomb, which is the 96,487 coulombs. So, i-substitute ra na siya from the work example nga akong gihatag ganina. So, ang current is equivalent to 0.03645 ampere times the 221.8 seconds mo ni siya ang time, times 158.1 grams per mole, mao na siya ang formula, mao na siyang equivalent formula weight sa sodium thiosulfate divided by 1 mole electron times the Faraday's constant Coulomb, which is the 96,487 coulombs per mole electron. So kung imo na siyang i-calculate tanan in a scientific calculator, dapat scientific calculator itong gamiton ani sa pag-calculate. Total na siya og 0.01325 grams of sodium thiosulfate. Ang kaning 0.01325 kay ang answer jud ana niya kay 0.0132479,784. So since ang gisundan sa 4 kay 7 man, so grand off siya, so mo na siya nahimo siya into 5. This represents the amount of sodium thiosulfate in a 10.00 ml portion of a 100 ml sample, thus 0.1325 grams of sodium thiosulfate is present in the original sample. The purity of the sample therefore is 0.1325 grams of sodium thiosulfate divided by the 0.1342 gram sample, which is naa ni siya makita sa given. If gawonder mo nga nung nahimo siyang 0.1325 grams instead of 0.01325, gitimes na siya sa 10.00 ml. Mo na siyang nahimo siyang 0.1325 grams of sodium thiosulfate. So mo na siya i-divide ang 0.1325 grams divided by the 0.1342 grams sample nga naa sa given ganina times 100, then i-calculate nimo mo total na siya og 98.73% weight by weight. Mao na siya ang percentage purity sa sodium thiosulfate. So di man siya kaayo lisod kaya mag-substitute raman and then multiply and divide. Note that the calculation is worked as if S2O3 to the exponent of 2 negative is oxidized directly at the working electrode instead of in solution. That would be all for my report. I hope you guys understand, especially sa katong mag-calculate na sa purity sample. That would be all. Thank you.